So today I will talk about consequences of homogeneity of space. So the consequences of this is that we can derive Newton's third law of motion from this, or we can say that Newton's third law is a consequence of homogeneity of space. And similarly, law of conservation of linear momentum is also a consequence of the homogeneity of space. So let us start with let us consider the homogeneity of space. So the homogeneity of space means all the laws remains invariant, or the it leads to the translational invariance of physical laws. It is due to translational invariance of physical laws, as we have discussed in the earlier lectures. So let us start with the potential energy. So for that, consider a coordinate system. Say this is a one frame of reference. Say it is x-axis, and say it is y-axis, and say it is z-axis, and say it is a S frame. So some particle is at the x-axis, say one particle is at p1 position and another particle is at the p2 position, and this is at a distance x from the origin. First particle is at a distance x1 from the origin, and second particle is at a distance p2 p2 is at the x2 position. So these are the positions of these two particles p1 and p2 when they are seen from the S frame. Let us now consider another frame of reference. Say that frame of reference is this one. Say it is z prime axis, it is x prime, say it is y prime. So it is at a distance a, means it is slightly displaced along x-axis, and say its position is a when seen from the S, means it is the position of S prime frame when seen from S frame. So that means if I now try to look at the potential energy of the particle when they are at the position at x1 and x2, then it is represented by ux1 x2, and u is the potential energy. Right? So u is basically a function of x1 and x2, and but when we have seen these two particles p1 and p2 from the S prime frame, then its potential can be written as u x1 prime and x2 prime. Right? But if I try to look at this p1 is basically means because when this is seen from this, then this distance is x1 prime, and say it is x2 prime. So let us try to relate the positions in the two frame of references. So from this particular diagram, if I try to look at this carefully, then what is this x2 prime or the x1 prime? So x1 prime, it can be written as x1 minus a, and it is x2 prime can be written as x2 minus a. So therefore the potential energy u prime can be written as u prime x1, or we can simply write down it like this: x1 minus a comma x2 minus a, because I just substituted these values here, so I can write down it in this way. But as we know from the homogeneity of space is that the laws of physics will remain the same translationally. So due to translational invariance we can say that potential will remain the same in the two frame of references. In other words, I can say that this u is x1 minus a and it is x2 minus a is equal to u. It is x1 and x2. This is the potential when seen from frame of reference and seen from frame of references, and this is the potential when seen from the frame of reference S prime. And but the potential will remain the same because it is translationally invariant. So let us try to look at this part now. So if we recall a very important theorem, we call that as the Taylor's theorem. So according to Taylor's theorem, if we know the value of the function at x, then the value of the function at x plus h can be written as f of x plus h f prime x plus h square over 2 factorial f double prime x. But h is very small, so if we ignore higher order terms, here prime means it's a derivative, so then fx plus h can be written as f of x plus h f prime x. So here it is depending upon two variables, so therefore if we apply Taylor's theorem for this particular, similarly means if x plus h by plus g or by plus h, then in that situation Taylor's theorem can be written as like this. This is f of x plus curly u over curly x plus curly u over curly y multiplied by h. We are expanding only up to the first term. So if I do this for this particular situation, then what we are getting, we can write down it as it is curly u, sorry, it is u x1 comma x2 plus, sorry, not plus, but here it is minus a, so plus minus a into curly u over curly x1 plus minus a curly u over curly x2 is equal to u x1 and x2. This will remain as it is. So that means I extended this using the Taylor's theorem or Taylor expansion, and this will cancel out with this because both looks identical. So here I can, if I take minus a common, so inside it is curly u over curly x1 curly u over curly x2, it is equal to 0. Minus a is not equal to 0, so that means this second must be equal to 0, right? So that's what we are getting here. So then that's what we are getting here. Now what should I do? As we know that negative of the potential gradient, so that means negative of the potential gradient means, or we can say that du over dx is nothing but it is the force on the particle due to other particle. So therefore if I apply this particular situation here, F means force, so then this means that curly u over curly x means what? It is the means if I take a negative here, means this is equal to rather than this, what should I do? Let me put minus here. So let me rearrange it. So let me remove it. Oh, sorry. Let me do one thing. Yeah. I can simply write down it like this: a minus curly u over curly x1 minus curly u over curly x2 is equal to 0. So that means a is not equal to 0, which implies minus curly u over curly x1 minus curly u over curly x2 is equal to 0. As we know that negative of the potential gradient, or the potential energy, its derivative potential energy with respect to x1, so that means it is the force on first particle due to second particle. Similarly, curly u over curly x2 is the force on the second particle due to first particle. So I can simply write down it as a f12 plus f of 21 is equal to 0. Or in other words, I can say that f of 12 is equal to minus f of 21. What does it mean? It is basically Newton's third law. What is it? It is basically Newton's third law. Newton's third law. We can say that means what does it mean? For every action there is equal and opposite reaction. Means for every action there is equal and opposite reaction, or in other words, I can say that when, say, we are having two objects, one is at A and the B. So when object A exerts a force on object B, then B also exerts an equal and opposite force on object A, right? And as we have started, or we have used the concept of here we have used the concept of what? Here we have started with the, or we have used the concept of translational invariance. And translational invariance means homogeneity of space and this leads to Newton's third law. So thus we can say that Newton's third law is a consequence of the homogeneity of space or the translational invariance. This is the first part which I have shown to you. Now as we did here that f12 plus f of 21 is equal to 0. So it is the force on first particle. So force on first particle is the mass of the first particle and the velocity, rate of change of its velocity. It is the definition of force, f12, and it is m2 dv2 by dt is equal to 0, because force is nothing but is the rate of change of momentum, or mass into acceleration, or mass into dp over dt. Not mass is not dp over dt. This is basically the force. So I am using this definition here, and momentum is nothing but it is a mass into velocity. So if I use this value here, then let me bring this here because mass is a constant. So d by dt, mass can be taken inside, plus similarly d upon dt it's m2 v2 is equal to 0. So let us take this here, it is m1 v1 plus m2 v2 is equal to 0. So as we know that the derivative of something is equal to 0, that means that something is a constant. As we know that derivative of some constant is always 0. So what does it mean? This means that m1 v1 plus m2 v2 is equal to 0, sorry, is constant. It's a constant, right? So in other words, we can say that, let us have a look at this part. What does it mean? As we know that this is the internal force, means total force acting on the system is, it is basically the sum of the internal forces, means no external force acts on the system, means when no external force act on the system, then what does it mean? Total linear momentum of the system is conserved. Then total linear momentum of the system is conserved. What does it mean? This is the law of conservation of linear momentum. Thus we can say that this is a consequence of the homogeneity of space, right? So thus we have drawn two conclusions, that homogeneity of space leads to the Newton's third law, and which further leads to the law of conservation of linear momentum. So that's all for this lecture.